Hello friends, today's question. Two particles of masses m and 2m moving as shown with speed of 10 and 5 meter per second collide elastically at the origin. If the collision, After the collision, they move along the indicated direction with speeds v1 and v2 which are nearly. So we have two masses m and 2m and they are making the angle of 30 degree and 45 degree with respect to the horizontal, moving with a velocity of 10 and 5, and after collision 2m moves with a velocity of v1 making an angle of 30 degree and m moves with a velocity of v2 making an angle of 45 degree along the horizontal. So we can divide this into two parts. Left side is our before collision and the right side is after collision. So it's given that they collide elastically, so we can use conservation of momentum. Conservation of momentum, and here we are going to take conservation of momentum in x and y direction. Okay, so this is our x direction and this is our y direction. So let us redraw the figure with their respective components. So this is mass m, mass 2m, angle of 30 degree and angle of 45 degree, moving with velocity of 10, and this is moving with velocity of 5. So we can divide to two components. Okay, so along this direction this angle is 30 degree, so we are going to get this as m multiplied by 10 cos of 30, and similarly we are going to get this component as m 10 sine of 30, and for the second component this is 2m, so we can write this as 2m 5 cos of 45, and this will be is another component that we can written as 2m 5 sine of 45. And similarly we can draw it for after collision also. So we have mass 2m moving with a velocity of v1 making an angle of 30, and we have 2m moving with a velocity of v2 making an angle of 45. So we can say this can be written as 2m v1 cos of 30, and we are getting this as a vertical component, that is in y direction. This will be 2m v1 sine of 30, and similarly this component will be 2m v2 cos of 45, and we are going to have component in y direction, in the opposite rather, negative. So this will be 2m v2 sine of 45. So these are the respective components in x direction as well as y direction. So conservation of momentum in x direction. X direction, we can write this will be m 10 cos of 30 plus 2m 5 cos of 45, that is the initial component, initial momentum will be equal to 2m v1 cos of 30 plus, this is m, my mistake. So this will be m and this will be m also. So we get this as m v2 and cos of 45. Now m and m cancels out throughout, and putting on the respective values, we get this as 5 root 3 plus 5 root 2 is equal to v1 root 3 plus v2 root 2. Let us call this as equation number 1. This was in x direction. Similarly, we can write for y direction also. So we say in y direction, we can write the equation as 2m will be v1 sine of 30, 2m 5 sine of 45 minus m, then it will be 10 sine of 30. This will be equal to 2m v1 sine of 30 minus m v2 sine of 45, and this m cancels out throughout, so we can write this as 5 root 2 minus 5 is equal to v1 minus v2 divided by square root of 2. Let this be equation number 2. Now adding equation 1 and second. So adding equation 1 and 2, adding equation 1 and 2, we get, so equation 1 was 5 root 3 plus 5 root 2 is equal to v1 root 3 plus v2 square root of 2, and equation number 2 is 5 root 2 minus 5 is equal to v1 minus v2 2. Now if we add them, these two terms cancels out, so we are left with 5 root 3 plus this will be our 10 root 2 minus 5, and this will be v1 as common, this will be root 3 plus 1. Therefore, we can say that our V1 is equal to, taking 5 as common, we are left with root 3 plus root 2 minus 1 divided by root 3 plus 1. So solution of this V1 will be approximately equal to 6.5 meter per second. Now we can use equation number 2. So using equation 2, we get V2 will be coming as 6.3 meter per second. So these are the velocities of 2m and m after the collision. So we have the answer as 6.5 and 6.3. So option number D is the correct option. You can say option D is correct. So this completes the question. Thank you.